Okay, let's look at some more facts about isometries, and remember what an isometry is. It is a mapping that preserves distances. So the fundamental theorem of isometries tells us that every isometry in the plane is the composition of at most 3 reflections. So if your isometry doesn't change sizes or lengths or distances, then to get from one set to its image, you can do it in at most 3 reflections. And specifically, exactly 2 reflections if it is a direct isometry. Okay, so the orientation remains unchanged under this isometry, clockwise or counterclockwise, and not the identity. The identity is the only one that's like saying f of xy equals xy. This, you don't have to do any rotations. You can do 0 reflections in this case. That's why the identity is just kind of the special case. Other than that, let's repeat that. Every isometry in the plane is a composition of at most 3 reflections and exactly 2 reflections if the isometry is direct. It doesn't change orientation. Okay, number 13. Again, a non-trivial direct isometry. The trivial one is the identity, and that's very boring, so we're not talking about that one. So a non-trivial direct isometry is either a translation or a reflection. Sorry, not a reflection. This needs to be rotation. Sorry about that. It's either a translation or rotation, because remember, a reflection gives you a mirror image that changes the orientation from clockwise to counterclockwise, or vice versa. Okay, number 14. The product of 2 translations is itself a translation. Let's verify this by finding T2, T1. So we're going to apply T1 and then T2. So effectively that means we're taking an ordered pair and we're applying T1 to it. And that result gets plugged into T2. All right, so here is our definition of T1. It takes an xy, and to get x prime, y prime, the output, it adds 5 to the x and adds 7 to the y. The second one, whatever it gets plugged in, I'm calling them x double prime and y double prime. It'll take x prime and y prime and add 3 to both of them. So let's see, maybe I can just write this down like T2 of T1 of xy is going to be, let's do the inside one first. What is T1 of xy? You go to the function T1. In other words, how do I get x prime, y prime here? You simply take x and add 5 to it. So this that I'm underlining, it's going to give me an ordered pair, x plus 5, x plus 7. And now I just need to apply this ordered pair, x plus 5, x plus 5, y plus 7, and apply T2 to it. Well, what does T2 do to an x? This would be our x prime, y prime. It adds 3 to both of them. So all I need to do is add 3 to this and add 3 to this, and I'll be done. X plus 5. If I add 3, I get x plus 8. Y plus 7. If I add 3, I get y plus 10. So this is the function. This is what T2, T1 does to the ordered pair xy. All right, number 15. Well, we might need to remember the midpoint formula for this one. Derive the coordinate equations, so x prime equals y prime equals something to do with x and y, for a half turn or a half rotation about a certain point AB. Okay, so if we were drawing a picture, maybe I'll do it way over here. Let me put C. That's the point C. AB, though, that's just its xy coordinates. That's the point C. And put the point xy anywhere you want to. Where would, let's put it here. Where would x prime, y prime be? Derive coordinate equations for a half turn, a half rotation about that point. That means it's going to be over here. You're going, this is like the center of a circle. We're traveling the circle until we travel 180 degrees, and it would put us to right about there. So that's going to be my x prime, y prime. How could I possibly get this? Well, remember, this point is AB. The coordinates are AB. The coordinates here are XY. The coordinates here are X prime, Y prime. I do know a formula for the midpoint. This is the midpoint of X prime, of XY, the line segment connecting XY to X prime, Y prime. And we know what the midpoint formula is. We know to find the midpoint, the A, which is the x value, and then b is the y value. The a is the average of the two x values here. That's what gives you the middle value. That's going to be x plus x prime over 2. And the b is going to be y plus y prime over 2. All right, so I need to just solve those for x prime, y prime, and we'll be done. So if I want to solve this for, maybe I'll write it over here. Let's start with this. If I multiply both sides by 2 to get rid of this fraction, I'll get 2a equals x plus x prime. And I want to solve it for x prime. So that would give me x prime equals 2a minus x. So I can go ahead and write that here, 2a minus x. And now I'm going to take the b, multiply it by 2 to get rid of this fraction. I would get 2b equals y plus y prime. Solving that for y prime would give me y prime equals 2b minus y. 2b minus y. This is the coordinate equations for a half turn around this point C, which has coordinates a comma b. Okay, let's finish up this section with the last example. Draw 2 points A and B. All right, and assume that B is the image of A under some rotation. Okay, so maybe I'll just put A here and put B here. Okay, so we're doing a rotation, and we'll assume this is a rotation about a point. So how could I get A mapped to B if I'm rotating about a point? Well, I know one easy one right here. We had an example like this one already. This point, if you took this as the center of the circle and you rotated around that circle, it'd take A to B if we rotated it 180 degrees. Is there any other point where I could rotate A and get it to B? Like, if I chose a point over here, it would certainly not work. If you rotate around this point, maybe right here, it's going to go like this. You're not going to hit B at all. But there are many other points. As a matter of fact, suppose I took this point. Can you think, is there a circle that I could draw that would map A to B? And there is. You know, something like this. It would just rotate it from A to B, and this would be the center of the circle. But it turns out that you could use any point that is equidistant from A and B. Any of these points. Any of those points could be the center of the rotation. So that would literally be all of them. Any point along that line you could draw a circle where there's a center on this line, and it would go through A and B. So the rotation would take us from A to B. So the answer would be any point on, how would we describe this? On, let's see, if we connected A with B, this would be the perpendicular bisector. So any point on the perpendicular bisector, which is a line, of line segment AB. That would be all of the points.